Well, hello, and thank you for coming to my presentation. Multi-tenancy has layers, peeling the Kubernetes one question at a time. First of all, I would like to also thank the organizers for having me here for the second year in a row. I had a talk last year, also kind of a multi-tenancy, was a little bit more focused on cross-plane, which I'm kind of an advocate to. So I am Carlos Mestre del Pino. I'm a cloud solution architect at Microsoft. And on my day job, I basically support Azure and AKS customers on networking, agentic AI, platform engineering, a little bit of everything from infra to apps. And in there, I do spend quite some time kind of arguing, discussing where we should be drawing boundaries. I'm also an organizer of or co-organizer of the Dutch Cloud Native Day. We have an edition coming at the end of October. Hope to see some of you in there as well. CFPs are open, so please also submit if you're interested to talk. Last but not least, I'm also a cross-plane advocate, and I am leading the SIG Prod Readiness, which is basically a special interest group where we are trying to define a standard for running cross-plane in production, going a little bit through cross-plane primitives, but also like how should you observe, how should you do like kind of like business continuity, disaster recovery, etc. So, for starters, we're going to start setting the scene a little bit. So our scenario is that IT leadership has decided that we need a multi-tenant platform. But why? Well, probably because I told them. But we're going to start going through or decoding that leadership ask. Because there's usually going to be some drivers around multi-tenancy. Number one, well, they're not really ordered by importance, but I'm going to start with the cost, where you're going to hear things like, oh, we need to consolidate N clusters into one, or into one cluster per environment or business unit, some kind of construct. Now, what they are really asking in here is that they would like to share resources as much as possible in order to reduce costs. We also have a speed, right? So that time to market. We're usually going to want a self-service onboarding for creating tenants, right? So something about a tenant API, not a ticket queue where your team picks it up and goes and creates a tenant. Another driver, it's of course the consistency and scale. So your IT leadership doesn't really want any more snowflakes or clusters per team, right? We're looking to optimize a little bit. That usually results or translates to like an opinionated platform with paved roads, automation, golden paths to production. And last but not least, of course, compliance and security. It's fundamental for multi-tenancy. In here, we're looking for tenant separation where the regulators are looking and sufficient guardrails to increase security. Your job as a platform architect, or platform engineer, is to turn those leadership asks into achievable layered decisions. And why do I say layered? Well, because platforms are like onions. They have layers. Now, I'm going to start going through each one of the layers. Some of them grouped a little bit together for simplicity. I only have half an hour. I would like to talk about this for hours, really. So what are the layers of our platform onion? First one is, of course, compute. So this is where your workloads are running. We have a network, so how each component is going to be talking to each other. Control plane or API, which is, of course, your entrance point to manage your workloads. The cluster services and tooling, which enable the platform team to manage the cluster and the tenants efficiently, as well as some tooling for developer teams. We have the identity and policy, so who is who and who can do what. And of course, we have the data and state, which doesn't really need much explanation, more to say that it's extremely important for compliance. But usually when we talk about this kind of separation, the most important thing is that, yeah, a tenant cannot see another tenant's data. Each layer has its own soft versus hard boundary choice, and I'm just going to first explain to you what this means. So we talk about hard boundaries when we're talking about physical or dedicated resources, which are typically enforced maybe at the cloud layer, so not always outside of Kubernetes, although I do have a couple examples of harder boundaries inside of a cluster. Now, when it comes to cost, this is going to be a bit more expensive because we're talking about dedicated resources per tenant, and obviously that's going to maybe make it a little bit less efficient. Some of the pros are that are simpler to reason about. So you either have a cluster or not, you have a network or not. It's a lot easier to kind of understand or see what is deployed. It's also easier for chargeback. You're getting all your costs directly from your cloud provider, so that's easier to charge back. With respect to some cons, this is going to be a little bit more rigid and slower to provision. In the other hand, you got the soft boundaries, which are usually logical constructs inside of a cluster or certain tools. We're also going to be looking at the separations inside of cluster services. Because you're sharing resources in here, this brings you to a little bit of a cheaper situation, and you can pack your workloads a little bit more densely on those shared resources. It allows you for flexibility. You just really need to go and change a YAML, and that also makes it fast to spin up or to make some changes. On the con side, a YAML typo can become an incident. Now, the choice between a soft and hard is mostly driven by 4 forces. So that is the trust, noisy neighbors, boundary breaches, and cost. I'm going to skip the cost one because I don't really like to talk about money, and I'm going to be focusing more on the first 3. So the first one is the trust axis, right? The boundary strictness is a function of trust between tenants. So for example, we may have a situation in which we are servicing a platform for internal teams within the same organization. So usually that trust is going to be high. And a typical posture would be to use soft boundaries as much as possible and shared services. We also have situations of like medium trust. So for example, different business units, merger and acquisition integrations, or perhaps also when we're providing access to partners. In this case, you're going to go probably for a mix of soft and selective hard boundaries where needed. We also have, of course, the situation where there is low to no trust, and that's usually going to be with external customers, but also maybe it's still within the same organization, but workloads that require, workloads that are regulated and require a lot of isolation. Typical posture in there, it's usually going to be hard boundaries by default. Now I want to talk about the 2 failure modes. We have a noisy neighbors. This is mostly around performance degradation. We have the boundary breaches, which is, well, a break of that confidentiality layer. So starting with the noisy neighbors, on the compute, you can have a CPU-heavy job. And for example, if you don't have appropriate limits, other pods may throttle. On the network, you can have high east-west traffic, which saturates a NIC or a CNI, bringing latency spikes. Or, for example, too much traffic going through a shared egress gateway, which causes performance degradation for other tenants. On the control plane API, well, we know that in Kubernetes, we got controllers, operators, which are constantly polling the API, writing or reading, and a controller that constantly hammers the API may also cause that kubectl and deployments throttle. On tooling, well, I just chose the example of Argo CD because I think it's a tool that a lot of people knows and uses. And if you've ever worked with a large Argo CD environment, you know that a 5,000 app Argo CD project is going to slow the UI down for everyone. For identity and policy, well, short-lived tokens and token issuance, OIDC discovery bottlenecks, it can cause like slow logins and failing webhooks. And on the data, of course, heavy input-output operations on shared storage is also going to cause latency. We move on to the boundary breaches, so that's when you can break out of a boundary and get to the other tenant, starting by compute, the container escape in which you reach the host. So of course now you're in the host where there's other tenants' workloads running. On the network, because we usually enforce through network policies, a bad network policy can create a flat network, or all of a sudden allow traffic between tenant A and tenant B, traffic that was not really meant to be allowed. On the tooling, on the control plane API, we can have misbound cluster roles. So all of a sudden you got cross-tenant admin on a tenant. Also, Argo CD projects on the section of tooling, you can have misconfiguration, right? So you are now deploying a workload into the wrong cluster. On the identity and policy, we have overbroad role bindings and perhaps shared storage accounts. So a tenant A can act as tenant B. And last but not least, on data, again, this is probably the most important isolation layer. You got tenant A reading tenant B's data. So the cost of a breach really scales with the trust gap between tenants. If you got tenants that really trust each other and something breaks in terms of breach, usually it's not going to be so much of a big deal. So now we're going to start slicing, peeling or slicing through our onion, and hopefully by the end of the talk you will not be crying. We're going to start with compute. This is the most obvious, the most common isolation layer, which has a big effect on performance, but as well, of course, on cost. For each of the layers, I'm going to ask one question. Well, we have two in the networking one. Obviously, you cannot define your multi-tenant strategy just on one question per layer, but again, I don't really have that much time. So we're going to start with, do tenants have strict performance or compliance needs? If yes, then you're usually going to go and lean for hard. So having dedicated node pools per tenant to provide that isolation. You can use tools like Carpenter to help right-size dynamically, but small tenants that need zone redundancy are still going to end with 3 nodes, which more often than not are also going to be underutilized. If you do not really need to provide a whole compute isolation for every tenant workload, but only for specific applications, you can have sandboxed runtimes such as Kata containers, virtual nodes, gvisor, etc., which give per pod VM isolation without that one node pool per tenant. That's a great kind of middle ground for only specific workloads. Now, if your tenants do not have those strict requirements, then you're probably going to just provide a namespace, and you need to apply resource quotas. So, of course, as to limit how much resources, so memory and CPU, a namespace can use, and also limit ranges. So, putting some sane per pod defaults and caps. This will keep things dense and cheap. Now, you do need to know that one misconfigured quota can cause unschedulable pods or run away out of scaling. And you also need to remember that you have a shared kernel, right, when you're running pods within the same node. So a container escape does become a cross-tenant breach. Moving on to the network, we look at it inside and outside of the cluster. And this is the only section where I put 2 questions because I would like to talk to you about north-south and also east-west communication. So on the north-south, we're going to start with how do tenants get traffic in and out, and do they need stable egress IPs? So why would you need a stable egress IP? Well, if your workload it's going out and querying something else outside or even inside of your environment, you usually going to allow that through a firewall. And you're only or some kind of whitelisting on that, on a SaaS or something. Now, you only really want to allow a traffic from the one tenant, not from all of them. So in that case, you can have that you need a stable egress IP or a per tenant web application firewall. Hard always wins. So you just provide a dedicated egress gateway with a fixed public IP, routed via NSG and firewalls. And for example, per tenant ingress do let you apply different WAF policies, TLS, and rate limits. For shared ingress, this is more typically fine if your tenants do not care about IPs. That makes it a little bit cheaper, also a little bit more dense, and you only have one cert pipeline, or hopefully no pipelines at all if you're using something like Cert Manager to automate it for you. Now, one tenant's bad route, huge volley limit, this can affect everyone. On the east-west, we're looking at is traffic between the tenants ever legitimate? And I have 3 different scenarios in here. So no, if it's never legitimate and tenants do not trust each other, what you can do is to have dedicated subnets and to put a firewall in between those subnets. Now, I cannot talk for other cloud providers, but at least in Azure, that does require compute isolation. You can only apply a subnet to another node group. Node pool. And network policies alone will not satisfy auditors. In a scenario in which the traffic is never legitimate, but there is a high trust, so for example, for internal teams in the same organization, soft is usually enough. You're going to have default network policies with explicit allow list for system pods, right? So that you can still talk to the core DNS and other components. You can also add, of course, a service mesh, which will provide you MTLS and identity-based path based off where you cannot trust the network. We also have, last but not least, the scenario in which, yes, there is traffic between tenants, which is legitimate, so you can go for soft with a service mesh as well, or no service mesh if you want to simplify. In this case, also, you will have allow list for cross-tenant workload communication, not only from the system pods. Sorry. Moving on to the control plane or API, this is where just give them a namespace can break. And in here, my main question is, do tenants need CRDs, so to install their own CRDs, the own operators, or cluster admin for whatever reason? If they do, you provide them with a dedicated cluster, which, of course, it's going to give strongest API isolation, but then you have N Kubernetes versions and N upgrade cycles. Obviously, providing with a dedicated cluster, that's already preventing you from sharing things like compute or network. You can share some of the other services, like identity, for example, or your Argo CD. Now, we also have a hard-ish way to kind of provide our tenants with that cluster admin or the possibility of install operators. That's with something like vCluster, which gives you a dedicated API inside of the same host. So tenants can get cluster admin without actually touching the host cluster. But now you are operating a component which was usually managed by your cloud provider, which is the API of your Kubernetes cluster. Now, if they do not need to install CRDs, then the most common pattern is, of course, that namespace, role-based access control bounds to OIDC groups, and of course, this keeps it cheap, dense, and well understood. Some of the caveats, of course, they cannot install their own CRDs, and cluster scope resources leak info across tenants. Admission webhooks are also global. On the cluster services and tooling, I'm talking about app projects in Argo CD, realms in Keycloak or in Grafana. Most tools, not all of them, but most tools do bring their own multi-tenancy constructs, their own ways to apply multi-tenancy. And in here, you need to ask, like, do we need to isolate for performance too? Because usually this kind of native way to apply multi-tenancy within the tools are only really isolating access. So who sees what, who can do what. Things like API rate, repo concurrency, query budgets, reconciles loops, all of this, again, stays global. So if access is enough, you can use soft boundaries with guardrails. And what is a soft boundary in this case? Well, again, in the case of Argo CD, that is a project which limits to what clusters you can deploy to. In that case, you do trust that native primitive, and you add the quotas inside of the tool. So what are the sync windows, query limits, rate caps, etc. Nevertheless, one runaway tenant can still slow everyone. So a tenant that it's deploying a lot of Argo CD applications, for example, will slow down the UI for themselves and for everyone else. So if you do need that performance isolation, you're going to go for hard or sharding, which is a per tenant instance then of that Argo CD or per shard instance. Now, if you do sharding, it's important that you plan that pattern before you need it, because retrofitting under load, like once this is in production, you just got yourself into a migration. We're on to layer 5, identity and policy. So who is who and who can do what. And in here, we're asking, can all tenants share one identity provider? So this is going to be more on compliance or perhaps preference of those tenants. You can also decide that you just don't do, you don't manage identity providers and you have to integrate with theirs. That's usually going to be more for external customers. So if tenants cannot share their own identity provider and they need to bring their own IDP, then you're going to have OIDC or SAML for logging. You can have SIM for sync user, create, delete. And in here, the tenant is managing their own lifecycle of that IDP. You have a scenario in which they do not need to bring their own IDP, but they can also not share one. So you're going to deploy one instance of that IDP per tenant. So for example, a per tenant keycloak with independent upgrade windows, but now you're managing n IDPs. Ideally, if you can share that and performance does not get degraded, you can go for a soft boundary. So that would be like a one shared ADP. Like if we're talking about keycloak, you would have like a one realm per tenant. Now, a single group claim is the one that has to drive the RBAC. It has to bind to Argo CD projects, Grafana orgs, roles on your cloud provider, etc. So recommendation is to normalize on a one-tenant claim. So the word is their claim because I work a lot with cross-plane, but again, this can be your one Helm chart, your one Argo CD project. Deploy a tenant as a one unit. Then let that, whether you're doing things through templating in cross-plane or Helm, or you can, of course, also let the policy like Kyverno or Gatekeeper to enforce those tenant labels, which will bring together the cost metrics and your GitOps. Sorry, I think maybe I need to do a little bit faster. Data and state. So we're one bad query, if we are one bad query away from another tenant's data. In here, the question is very obvious, right? What if tenant 1 gets to tenants 2 data? And this one's a little bit different than the other questions because it's not so much about preference, but it's more about thinking about the potential consequences of a breach. So if tenant 1 sees tenants 2 data and nothing happens because it's on their own team, then it's OK. You can have soft boundaries with shared storage classes to simplify. Maybe there may be an awkward Slack or Teams thread. So that is, so you should apply soft with discipline. You need to have a strong policy and also, of course, real tests before rolling anything to production. If you would lose your customer, then you need to apply hard at a logical layer. You can have separate storage classes, databases, buckets, keys. If you are going to end up in the news or sued or fined, then you want to apply that hard layer, that hard isolation at physical layer, separate storage classes, storage accounts, tenant held keys, backups. You want to isolate that as much as possible. Now, data isolation, then it's not really about technology. It's what about a leak will cost you. So after navigating through soft and hard boundaries for each of the layers, what is the right answer, right? What should we do? Well, you know that the right answer, it's always 42, because if you don't ask the right questions, you're not going to get the right answers. And that's exactly why you do need to ask them. Hard boundaries are expensive. They're simpler, and they're a bit more predictable. And you do have the soft boundaries, which are cheap, dense, but a little bit more fragile to misconfiguration. So testing, testing, testing. Most platforms are a mix, layer by layer, and this is driven by trust, cost, compliance, and was not mentioned in the beginning, but also team capacity, right? There's only so much your team can do. I did want to give you with a decision template per layer, so that also when you need to think and formulate these questions, for each of the layers, you should write down, like, what is the purpose of the boundary? Am I trying to isolate for security? Am I trying to isolate for performance, optimize cost, or optimize operations? What is the cost of hard isolation in there? Because if it's cheap, you can probably just go for hard because it's simpler to manage and to audit, of course. Now, what breaks if the soft boundary is misconfigured, and also like what the consequence will be? And who owns the boundary day to day? Most of the times, that's going to be on the platform team. Of course, how do we test that everything still works tomorrow? If you cannot answer all 5, you don't have a boundary, you have hope, and hope is a terrible strategy. I do want to leave you with a few key takeaways. So multi-tenancy is not a single decision, it's a stack. Each layer is going to have its soft versus hard trade-offs, right? Nothing is perfect. You're always going to have to compromise on something, so pick intentionally. The trust between tenants is driving that strictness for your layer separation more than technology does, really. And of course, your soft boundaries are only as good as your automation and test are behind them. Less about layers, but for me, always still recommendation, expose your platform as an API and hopefully as well an API for creating tenants and bundling all the resources together. And ask the questions before you draw the architecture and not after the incident. With that, thank you very much. I do want to add, sorry, I will be uploading the slides as well. Please, if you follow me on LinkedIn or something, you can find me at Mestre del Pino. I should have done the QRs like Marcus did. You're very prepared, mate. And also, I just added some appendix about just some summaries about the different layers. And of course, one question is not enough to define your strategy. So also some extra questions for each of the layers. Thank you.
Awesome. Muchas gracias.